This meeting is being recorded.
On knowledge transfer and intellectual property, that is going to be taken by Giovanni Anelli. Giovanni is as a Master of Science in Electronics Engineering from the Polytechnic of Milan, and the PhD in Electronics Engineering from the Polytechnic of Grenoble, and also an MBA that has been taken at the AIC in France. Giovanni worked for 10 years in CER's microelectronics group at the physics department, designing several low noise, low power analogs and mixed signal circuits for high energy physics applications. His research work also dealt with techniques to design radiation tolerant integrated circuits in deep submicron MOS technologies, an approach which is now employed by a large majority of the integrated circuits of the Large Hadron Collider at CERN. Giovanni then joined CERN's Knowledge Transfer Group in 2010, and he is appointed as head of Knowledge Transfer Group since August 2011. So, Giovanni, please, the floor is yours.
Thank you. Thank you very much for the introduction. Good afternoon, everybody. It's a pleasure for me to be here. I'd like to thank the organizers for inviting me to give this lecture. And it's really a pleasure and an honor. And I like to start by sharing my screen. You find my slides on Indico, of course. And this, can you see my slides?
Yes.
Very good. So I like in this lecture, I like to walk you through what we mean by knowledge transfer and technology transfer, and how intellectual property rights can help technology transfer and knowledge transfer. Of course, most of the examples I'm going to show are related to what we do at CERN, but I think that the general principles apply to any research institution who wants to do technology transfer. So my talk is really split in two. First, to explain how we conceive knowledge transfer at CERN, and then to show a little bit how IPR can help this process. So as you might know, at CERN, we have the mission of the organization is based on four main pillars. The first one is the science. So CERN is the largest fundamental physics laboratory in the world. And our mission is very, very clear, fundamental science, and in particular high energy physics and particle physics. But to really exploit at maximum our mission, we constantly need to build new research infrastructures, detectors and accelerators, and with all the computing infrastructure which goes with it. And therefore, what we do at CERN actually is develop a lot of new technologies together with industry. And the second and the third and the fourth pillar of the organization are training and cooperation. But I would say when we speak about knowledge transfer, technology transfer is in particular this aspect of technology development and innovation that we care about. And again, this is something which is general to any academic institution where you develop new knowledge in certain fields, and then you can transfer it to society via industry very often. So in the case of CERN, high energy physics, our toolbox is really made of accelerators, detectors, and computing. And those are the macro areas. And inside each one of those, you have a lot of technologies. You have magnets, you have cryogenics, vacuum, high-speed electronics, low-noise electronics, materials, cooling, ventilation, data storage, etc., etc. So there are many, many areas. And what we do at CERN, but in general, the idea behind technology transfer or knowledge transfer, and I will explain why I speak more of knowledge transfer than technology transfer, is really try to understand how what we develop in a research environment can be transferred to society at large in other fields. In this slide, we mention a few. You see safety, medical and biomedical, very relevant to HITR+, of course, cultural heritage, aerospace, there are many. And really what we want to do is to make sure that what we develop at CERN, which we do for our own research purposes, if it is useful to society in other fields, it will be. CERN is known for having invented a World Wide Web, which is a good example of something that we did because we needed it at CERN. We wanted to help the worldwide physics community to better communicate. But it's a very good example of something that has happened because we had some ambitious scientific goals and we ended up doing something which is very useful. Now, what we call knowledge transfer is really, and why we speak more about knowledge transfer than technology transfer, because for us, I mean, technologies are included in knowledge, okay? So when we talk about knowledge transfer, we think about what CERN has developed in terms of technology, but also know-how and also the infrastructure. I will have a few examples later to illustrate why also the special infrastructure we have might play a role in knowledge transfer. And so what we call knowledge transfer is really understand how those competencies that we have adopted at CERN can be used in other fields. Let me, for a second, give you an example of something which had happened in the 70s. And why since then many things have changed at CERN, but also in other institutions. So this picture, you have three pictures actually. Top right, you see this gentleman with a red jumper. He's a Danish engineer, now retired. And at the time he was asked, could you please come up with some tools which would allow us to control our accelerator in a more user-friendly way? So in 1970, I think probably nobody of the people attending this course or the students was there. And so you need to jump back in the past and understand that the computers at the time were very, very different from what we have today. So what he did, he came up with a prototype of what at the time was called a trackball. So today, we have the mouse of your computer. They're all optical. Before being optical, there was a little ball underneath, and by moving the mouse on your desk, the ball would rotate and would allow to move the arrow on the screen. And if you put the mouse belly up, you have what you can see here. Do you see my arrow if I move it on the screen?
Yes.
Yeah, very good. So you see, this is a ball, and by moving the ball with the hand, you move the arrow on the screen. There are some potentiometers inside here. The guy bought a bowling ball, and he came up with this prototype. Now, and the other picture shows his daughter actually holding one of the very, very first prototype of a capacitive touch screen. Okay, so this is again, 1973, I think. So if you put your finger on the screen, you send a signal which allow you to put the cursor where you want. Now, CERN is not so much associated with the inventions of those two technologies. So what has happened is that those were invented at CERN, and in parallel there were other places. And if you want, things went in a way that the same things were invented at the same time in multiple locations. But if you think about it, for CERN, it's a pity that at the time, we did not have an active effort of saying, okay, but this thing that we just developed for CERN, for our control room, could be actually very, very useful to other people. And that's how a few years later, there was at CERN this impetus of saying we should make sure that when we do something clever, which is used at CERN, but could be used elsewhere, we make sure that this happens. So before I really move into the knowledge transfer that we do specifically in the knowledge transfer group and how we use IPR for that, there are multiple channels that any organization use to do knowledge transfer. So the first point there is, really dedicated actions to foster the transfer of technology and know-how to other fields than particle physics. So this relates a little bit to what I was saying. Make sure that if we do something clever, we know it and we try to transfer it to others. But there is also a lot of knowledge transfer which happens through technology-intensive procurement contracts, for example. An example is whenever we buy something high-tech at CERN, and we buy it for CERN, a new magnet, it is not rare that what we are asking is new. So we push companies to innovate, to be able to supply what we need. And in this process, often companies also need our help because they never did it before. And that's why there is, procurement is also available for a vehicle for knowledge transfer. And then people. And I think this, while it's very hard to quantify, is extremely impactful for particle physics if we count all the young people who come at CERN at the beginning of their careers or as a student, and they stay a few years and then they leave it and go somewhere else. Clearly, they are available for knowledge transfer. They come here, they learn things from our more senior scientists, and then thanks to this know-how, they hopefully find a nice job somewhere else and off they go. So now I will focus mostly on the first part of this slide. So really, what can we do and how we do it to make sure that what we do at CERN is also transferred to others. So that's why at CERN we have this group which is called the Knowledge Transfer Group. You also, if you are curious, you can go to our website, kt.cern. And the mission of the group within the mission organization is, the first one is really maximize the return to society in terms of technology and knowledge, and in particular to member states industries. CERN is a publicly funded research organization, and we want to make sure that what we develop, thanks to the taxpayer money in the member states, goes back to society. And I'm really talking about society, okay? So for us, society at large is important. But when we speak about knowledge transfer and technology transfer, industry is a very important vehicle for this to happen. And of course, in this case, we work primarily with member states industry, not exclusively, but primarily because the member states are the ones who pay the CERN budget. The second part of our mission is also promote the image of CERN as a center of excellence for technology innovation, because CERN is very known for the physics, less as an innovation hub. And then the last point is help the organization to demonstrate the importance and the impact of fundamental research investments. We at CERN, we know that those investments have a good return on investment, but of course there are trends in all our member states of financing more applied research, or other fields of research today seem, at least on paper, more interesting than high energy physics. And that's why we have to have this constant exercise and effort to demonstrate that what we do at CERN is useful to others as well. One important concept, and again, it relates to knowledge transfer, is why do we call it knowledge transfer and technology transfer? Because what actually is of value for society and our partners outside is the competence that we have. You find here a lot of words where I really mentioned some of those. And let me explain. The technologies that we develop at CERN are very specific to our own needs, our own problems. And very rarely people outside have the same problems we have. So if we try, as we have done at CERN, and again, this was a common problem of many technology transfer offices, to do what in our jargon we call technology push. We go outside and we tell industry, hey, we have this technology, do you need it? Most often, what we are offering is not as it is useful to them, because we are trying to sell a solution to people who don't have the same problem we have. Okay, I give you just an example. You know that at CERN we have the Large Hadron Collider. It's a 27-kilometer long machine, which is all cooled down at minus 271 degrees. And one of the inventions that was made at CERN was a kind of distributed sensor to measure the temperature along the LHC, so along a very long distance, and a temperature of minus 271 degrees. So if you go outside and say, who needs to measure a temperature of minus 271 degrees over a very long distance, you will not find many people which have this issue, okay? While if you look at why did we develop it? Why didn't we buy it? And the reason is that it didn't exist. And no surprise, it didn't exist. It's not a problem many people have. But then when we start discussing with our scientists and to understand what were their competencies that they used to develop this technology, that's where things immediately become more interesting, because some of those competencies could be used to develop other solutions to problems that people have outside. So today, really what we do in the Knowledge Transfer Group is we try to understand how can we match the competencies that we have developed at CERN to problems of people outside. And immediately, if we manage to do that, things work much, much better. To illustrate this, I'm going to show you some examples so that I will make this a bit more clear. So this picture shows something that I mean, you understood at CERN we are very good in making particle detectors, and therefore those can be used in medical imaging. And there is a startup company which is called Mars Bioimaging, which is using one of our technologies, which is hybrid silicon pixel detector. So a detector made of pixels, which is similar to what you have in a digital camera, if you want, but much higher performance. And they use it in a CT scanner. So a CT scanner is where, you know, if you make a radiography, you have a source, you have the patient, and you have the film or the digital film, let's say. And then if you rotate the source and the film around the patient and you take multiple images, then you can make a three-dimensional reconstruction of the patient. And the detector that we have made, so this technology that was developed at CERN, allows to obtain much better images, more high quality, because of a number of technical features that maybe I don't have time to enter into now. But the interesting story here is that the chip that is used by this company is not the detector, it's not exactly the same as the one we have in LHC, because the needs they have in this medical application are different than the needs we have in the particle detectors for energy physics. But the competencies that we use to develop it are the same. So if you want, the story is that we developed some very high performance detectors for the physics experiment. And after we did it, we realized that those were potentially very interesting for a number of other fields, including medical applications and medical imaging. And then we redesigned a new detector specific for medical applications. So you see how at the end it's not the technology which was transferred as is, but it's more the know-how behind it, which was used to make something which was addressing a problem that people outside had in an application rather than the same problems we had. The same technology is used in many other applications. Here you see a picture taken on International Space Station, and you can see there is a laptop here, which has a kind of USB stick inside. If you look at the zoom here, you can see there is the CERN logo on it. And actually, so this is not a USB stick, it has a USB plug, but there is a detector on it. And there is a project ongoing with NASA and the University of Houston to make a very high performance dosimeter, which is important for space exploration. The same technology used by another startup company, using Medipix as X-ray eyes for cultural heritage. And those are three examples of the same technology used in different fields. The same technology is used in other fields as well. I don't have time to mention all of them. Now, if you speak about accelerators, well, I cannot not to mention CNAO and Medoston. Maybe I will not spend much time on it because you know it all. But if you think about it, it's also the story is always the same. I mean, we at CERN have developed a lot of competencies in accelerator physics and how to build accelerators. And in the 90s, it was this study made, which was called Proton Ion Medical Machine Studies, which was done at the end of the 90s, where we put together a lot of competent people at CERN and in other institutions that you can see mentioned on the paper here. And they made a first study of how we could use our competencies to make a machine to treat cancer. And then this from Terra went to CNAO Foundation and INFN. They made a center in Italy, CNAO. And after that, we also helped the construction of Medoston. Now, you can see here, the picture shows treatment room in CNAO and the accelerator in Medoston. And those tend to be very bulky structures. So what we are doing at CERN today is try to understand how we can make accelerators smaller. And this shows just an example. Of course, I'm cheating here a little bit. This does not compare to the previous slide. It's just a part of a machine. But this is a radio frequency quadrupole, which is extremely compact. So an RFQ is something which allows you at the same time to accelerate and focus particles. And we made this object, which is today licensed to a company which is called Adam, which is making, and I think you will have something in the program later this week. So you will hear everything about what they do with it. But also we have a number of other projects related to that. And one is called Machina. This is again about cultural heritage. if you want to study an object before you restore it, a cultural object before you restore it, you can use X-rays techniques using X-rays like X-ray diffractometry, or you can use other techniques like proton-induced X-ray emission. So you, instead of shining X-rays, you shine protons on the object and you see what comes out of the object. And this is a technique which requires an accelerator. The Louvre, the museum in Paris, has one, but they are the only ones. So the accelerators today, which can be used for this technique, are very big. And Machina is about trying to make a more compact object which can be transported to museums instead of trying to move the paintings from the museum to the accelerator, which is very complicated, you can imagine, for the insurance reasons, etc. And so this is another example of technologies from high energy physics which can be used in other fields. Maybe a couple of examples more from digital. We have at CERN, we made a software for library management, which is open source. And this is a whole chapter of my presentation after a whole chapter. I don't have much time, but a few slides will be exactly on that, open source. So we do license a lot of our technology with open source techniques. Open source something means that people can use it and is free to use. It does not necessarily mean that it's easy to use. And so we still help people to use our software open source to their application. And in this case, the idea, so we had this software which was interesting for many other people outside CERN. They started to use it. The challenge was that all those people then was coming back to the people at CERN who developed the software saying, can you please help us because we have, I don't know, we need to understand better how it works, etc., etc. And this was not sustainable to us. So we have created this spin-off company, which is their business is actually helping others to use and adopt our software, and then they help with installation and running it, etc., etc. Still in digital, we have a partnership with a German state-owned company in Germany. They are working on the next generation ideas for identity management, so passwords. And well, I mean, this is still very early stage. We don't know exactly if what we are doing together will lead to a password that you cannot copy easily. But you know, this is really advanced research, but there are a number of areas in which we are collaborating. Something that we are also doing with a company from the Volvo Group is understanding how the technologies that we have developed at CERN to analyze the very large quantity of data which are produced by the LHC experiments can be used in autonomous driving vehicles. So you need to imagine that inside the LHC experiments, you create a deluge of data, and we need to understand very quickly whether what the collisions have just created is interesting or not. So you need to imagine that there are about 1 billion proton-proton collision per second inside each experiment, and only a very tiny fraction of those is sent out of the experiments. So inside the experiments, you have a lot of built-in electronics, which looks at those 1 billion collisions, and very quickly decides what is interesting and what is not. And to do that, we have developed some techniques. And why autonomous driving? Because if you think in a car that drives on its own, you have a lot of sensors around the car. And again, you have the issue of analyzing all the data very quickly. You want to make sure that if a child crosses the street, the car stops immediately. And so we are working with this company to understand if they can reuse our technology inside of one of their vehicles. So I finished the examples, and I made this example just to make you understand a little bit what we do at CERN. But as I said, I think this is very general. Okay, I think in most of the laboratories where you do fundamental research, you base yourself on the competence that you have. Now, in other, if you look at applied university, then I think what happened is slightly different, because very often, if I take, I don't know, the MIT or EPFL or any polytechnic, they tend to have a lot of contract with companies, and that's what's happening is a bit different. So companies might want to subcontract to research institutions some of their R&D, and of course, when they do that, they pay the university or the research institution to do what they need, and if it works, they immediately have a case of technology transfer. But this is really when the university is working on something which is already geared toward the application. What we do at CERN is different. The innovation we produce is for our internal purposes. And what we try to understand is if the knowledge behind the innovation can be used in other fields. Now, this slide shows an ecosystem that we are trying to put together, because I mean, this process, as you have understood, is not happen naturally. Remember the example of the trackball and the capacitive touch screen. If nobody did anything at the time, and those things which we did at CERN were not used by others. Okay, so that's why we have put together an ecosystem which is made of many ingredients. I will not have time to go through everything in this slide, but let's say one part, I mean, what we do is really about intellectual property management. Okay, so understand how we manage the intellectual property for the organization, and this happens with different kind of tools. So we have R&D collaborations. That's when we collaborate with a company to understand how we can adapt our know-how to their needs. We have license agreements of different kinds. We also have service and consultancy agreements. I mentioned infrastructure before. We have some very special infrastructure at CERN, like we are able to test objects at very high magnetic field at cryogenic temperatures. There are not that many places where you can do the two things at the same time. And for us, it's really normal. And so we can also give access to our infrastructure to people outside who need to do certain tests. But on IP management, and I mentioned here the patent portfolio, the rest of my presentation will be about this. Open source, that's important. I mentioned it already. So one way of licensing is through open source, and we also use it quite a lot, in particular for software. We also have been behind the creation of our open hardware license, because open source software licenses, they have a lot of different flavors. Open hardware, not that many, so we did one at CERN. And then we have a number of other aspects. Well, we have some funding opportunities for certain project when we have an idea on how to use a certain tech in another field, and we struggle to find a partner because the idea is really early stage. We might invest a little bit of money into it to make a prototype. Entrepreneurship is also something I like to mention, because something that we also do, and this again is common to all research institutions I know. We are happy to work and to transfer our know-how to existing companies, but also another vehicle to do technology transfer is by the creation of a new startup company. So I'm right in the middle of the presentation, and I like just to stop and see if there are any questions from the audience. And I planned in any case to finish a bit before 3, so there will be time at the end. But if there is any question or something not clear, you have an opportunity to ask now. And if not,
it seems everything clear so far.
Okay, so far so good. Then I move on. Okay, very good.
Okay.
So now I come to the second part of the presentation, which is intellectual property rights. Now, of course, in 1 hour, I could not possibly cover all the details of intellectual property management and intellectual property rights. Also, as was mentioned at the beginning, I'm an engineer, so I'm not the expert of this. There are, I mean, in the group at CERN, we have a lawyer who is intellectual property lawyer, so her field of expertise is exactly that. But I think I know enough to give you an introduction. In particular, what I want to say is not so much about the legal details of it, but what is useful for you to know. Okay, so if we talk about intellectual property rights, there are a number of things that a number of different IP rights that exist. You probably have heard about patents, but you also have copyrights, trademark, and trade secrets. Those are the 4 more known. Then you have also something very special. You have IC, integrated circuit layouts, plant variety, some geographical indications. But I would say that patent, copyrights, trademark, and trade secret is the most common forms of protection of intellectual property that you should be aware of. Trade secret, I will not speak about it. In the rest of the presentation, I just mention it here. If you are a company and you have developed a technology and you want to protect it, one way to protect it is to keep it secret. Think of the Coca-Cola company recipe for Coca-Cola. Okay, and when does this work well? If you're a company, which CERN is not, when your invention is something that you cannot reverse engineer from the product. Okay, in this case, companies might consider to protect it with a trade secret. Why? Well, because if you patent it, you are actually making public. Okay, so you are telling others how you did it. And even though in theory a patent protects you because it says that the technology is yours, still people can copy you, and before you find it out, it might be very difficult because you cannot discover this by reverse engineering the product. And also then patent litigations are very expensive. So that's why trade secret is certainly something which is used in industry. In the rest of my talk, I will focus mostly on patent, trademarks, and copyright, and in particular on patents. So what are the characteristics of some of the intellectual property rights? So patent, trademark, and copyright. So patent, the rationale is an incentive for inventors. And basically it says, if you invented something, if you tell the world what you did through a patent, because a patent is a publication, we give you the right of saying, this is yours, and I decide what I do with it. Okay, so I'm kind of protected, and my invention can be used only if I allow people to use them, and I set the rules. Okay, so this is about inventions. The criteria we will see later should be new, inventive, and industrially applicable. It requires a form of registration, which, by the way, is pretty expensive, and it covers you for 20 years. So if you have patented something, you have the right. First, you have a piece of paper which says you are the inventor and you were the first one who had this idea, made this invention, and you decide for 20 years what others can do with it. And after the 20 years, it goes in the public domain. Everybody can do it, can use it. Then trademark is more to avoid confusions about source of goods and services. So the subject matter is words, phrases, symbols, designs. Okay, think of the logos of companies or things like this. The criteria here really is it should allow, a trademark should allow you to distinguish goods and services. That's why some brands are recognized. You know, Nike, you don't need to see the word Nike on a pair of shoes. The logo normally is enough to tell you that those are Nike or Adidas, etc., etc. And the companies use trademark to protect their image. So this is certainly something that we at CERN use very, very, very little. And registration, while it depends, in most of the cases it requires a registration, but you can have some de facto protection just because you use it even without registration. But, and the duration is indefinitely subject to use also. If you don't use it anymore, then you might lose the protection. And then copyright, well, this is known for, in particular for authorship. So is a protection of authors. It covers works of authorship, which should be tangibly expressed, okay, like a book. The criteria should be original work, so no copy. It doesn't need registration. It's normally life of the authors plus 70 years or 70 years after the publication. Now, IPR and CERN. I mean, honestly, this is something I've been thinking quite a lot when I came back to CERN into knowledge transfer, because you say, well, IP rights are rights to prevent others from doing a number of things. That's actually, well, I mean, that's not exactly what we want to do at CERN, right? I mean, we want to disseminate our knowledge and allow other people to use it. So we try to see things differently here and say, well, IPR are something we can transfer, okay? And they give us the right to enable others to use, manufacture, sell, import, use a trademark. I mean, you know, to exploit our intellectual property under agreed conditions. And there might be occasions in which you welcome the fact that you can control who uses it. And that comes to, I mean, a crucial part of this presentation is we have the public domain, you know, everybody can use it. At the top, at the bottom, you have protected dissemination like patents, etc. In the middle, you have what we call open dissemination, which is open source licensing, okay? I mean, how do we do it at CERN? I mean, CERN is an open lab, and it is in our convention that we should be as open as possible. Okay, so we use a lot of open source licensing, as I mentioned, but in some cases, to allow other people to use your technology, you might want to go to a patent. Example, if the adoption of the technology, to use our technology in a product requires a big investment from industry, that's typically where they would like to have a license on something like a patent, which would allow them to fundraise or use internal funding resources. When this is not the case, then we go for more open source licensing. So this is really to say that patents can be a vehicle for technology transfer, and it varies a lot from institute to institute how they are used. In the case of CERN, where our main driver is make sure that others use our technology, we don't use them so much, except when they are really useful, as in the case I mentioned. But if one of our technologies can be used as is by others, we very often go for open source licensing. Now, I thought that as patents is what, I'm really thinking at the students here and what in their life might be useful for them to know. And that's why I'm going to spend the rest of the presentation primarily on patents, because this is what most of you will probably have to be confronted with one day or another in your life. So a few concepts on patent. What is a patent? What can you do with it? And how can you obtain one? So there is something called the patent system. I have something on this a bit later. And what you do, you apply to get your patent recognized, and I'll explain later, okay? And this, after you have done it, can lead to two things. First, a publication. As I say, the patent is a publication, and there are databases of publications which are free for people to consult. And at the same time, gives you a granted patent. So you are the applicant, and you are granted a patent, which then you can use as you want. Now, in a patent, very important, you have to distinguish between the applicant and the inventor. So in the case of CERN, our personnel, who is paid by CERN, when we as an organization file a patent, the applicant is CERN, because the intellectual property of our employees belongs to CERN. That's very standard. We pay you, and if you invent something, this will not belong to you personally, but will belong to the organization. That's why we file a patent as an organization, and the applicant is CERN, so the intellectual property and the patent belongs to CERN, but the inventor is the individual, and his name or her name is on the patent. So what is a patent? It's actually, as I said, a publication which contains a number of crucial elements. So some bibliographic information. You can see language in which when it was filed, in which language, and then you can see, well, the applicant. Okay, so that's, you see, Apple. And then inventors, you see, that's the name of the person. And in this case, the people, because there are many. Okay, so you have some information like this. You have an abstract very often, so it's like a scientific publication. You have an abstract which explains in a few lines what the invention is about. You then have a description. So a patent can be several pages, like a scientific publication, and then you go really into the depth of describing what the invention is about. You do it also with, of course, drawings, exactly like scientific publication. And then, different from a scientific publication, you have what you call the claims, okay? And basically, at the end of the patent, you say, I claim that I invented something which can do all those things. And there are many, many, many claims in a patent, okay? So you claim what your invention is able to do. What can be patented? And this is very important. There are 3 criteria for something to be patented. It should be new, which means that if even yourself come up with an idea and you publish it, at the moment in which you publish it, it's not new anymore. Okay, so when you publish something, you disclose it to the world, and therefore is not new. So it must be new, it must be invented, so it should not be something. The jargon says that it should not be something that is obvious to a person skilled in the art. Okay, if I come up with an invention in microelectronics, I'm a microelectronics engineer. I don't expect somebody who has no background whatsoever in microelectronics to understand it. So it's not those people who should judge whether it's invented or not. there are other microelectronics engineers should be able to say, oh, this is a really good invention, or, oh, but actually this is trivial. We have not invented anything new. This is so obvious that no reason to patent this. And then industrial applicable, okay? So it should not be something theoretical. And when you file, the date in which you send this to the patent office, as the date of filing, is the moment in which you define what the prior art is. So to define whether this is new or not, the patent offices will look at all publications that they find before the date of filing, so the prior art, and they will use that to define whether you come up with something new or not. What are not inventions? Well, discoveries, scientific theories, mathematical models, aesthetic creations, so you have a few. I mean, again, these things here tend to become pretty complex quickly. So it's easy, I think, to define what really you can patent. So how is a patent obtained at CERN? And I mentioned at CERN, but again, the process is pretty similar, regardless where you work. In the case of CERN, as we take very, very, very few patents for the size of the organization, the research budget we have, we subcontract most the work to patent attorneys, okay? Apple, of course, they have their own internal patent lawyers which do all the work because they file a lot of patents. That's not the case of CERN. So there are four actors here. So there is inventor, there is the KT group. We are the first point of contact for people who think they might have something which could be patented. And then we deal with the patent attorneys who then deal with the patent office. But as I said, this KTIP or patent attorneys could be, in some cases, integrated directly in the same structure together with the inventors. So, first thing, somebody comes and say, I think I invented something. First thing we do our little assessment and search. So we in the group, we discuss with our scientists and we try to understand if the three criteria that I mentioned before are fulfilled. Okay, so new, inventive, and industrially applicable. And we might also do a little bit of search ourselves, not in depth, but just, you know, before we contact our patent attorneys, and then when we contact them, we also pay them for every hour they spend. We want to make sure that, for example, our scientists have not already published the same thing. Okay, this happens very often. Okay, once we have done our first analysis, if we think that the invention is patentable, but also most important, it makes sense for CERN to patent. Okay, and this is, as I mentioned, not always the case for CERN. We don't patent everything which is patentable. There are some research organizations in which the innovation of the organization is measured by number of patents, and therefore they patent whatever they can. That's not what we do at CERN. We think that this is not the right thing to do for the organization. And in most of the cases, when we think is the best way to disseminate our technology, we go open source and we don't patent. Okay, but so if in the rare cases at CERN in which we think, oh, this could actually be interesting for CERN to patent, then we contact our patent attorneys and they do a novelty search. So they do a much more, they have tools that we don't have, and they are much better than us in trying to understand whether this invention is new or not. If they say, we haven't found anything in the prior art, so it really looks that is new, then there is another phase of an assessment which involves the inventor, ourselves, and the patent attorneys. And this is again about trying to define, okay, what is the invention about? What do we want to claim? Okay, so for example, if you invented something, you need to put numbers in the publication. Okay, say if I invent something to, I don't know, I need a new thermometer, I want to be able to say, and I think my thermometer works particularly well in this range of temperatures. And these are a lot of discussion you might want to have, because your interest as filing a patent would be to put the range as wide as possible, so you have a broader coverage. But if you put it too wide, you might infringing other patents. Okay, so there is this fine balance between making the coverage of your patent as wide as possible, but not too wide that you end up not having something new anymore. So this is a very complex process. Once we have defined all this, the patent attorneys will do the drafting for us. And this is really a specialized job. When I worked in industry for a few years, I took a patent, and the first patent I took a few patents, and the first patent I took, I tell you, I was asked to send it to the patent attorneys the description of the invention, etc., which I did, and I wrote something like a scientific paper. This is what I knew to do. And when they sent the patent back for me to read it before they filed it, honestly, for the first 30 seconds, I thought, oh, they sent me the wrong file. I could not recognize my own invention. It's a very special language what is used in patents, and that's why you need to use patent attorneys, so lawyers specialized in patents. Well, after they drafted, we review it again all together. So this is reviewed by the inventors, by us, and the patent attorneys. And finally, this is filed. And there are multiple ways in which you can file it. There are National Patent Office, European Patent Office, there is the World Intellectual Property Organization. So you can use different filing strategies, but I will not enter into this. But so the filing, you fix the date of filing. So you have finally sent your patent to the patent office. That doesn't mean that you have a patent. You just filed it. And the date is important because nobody can file the same invention. So if somebody invents the same thing after you file the patent and they do the same, you are protected by the fact that you filed first. Then from the date of filing, there are many things which happen. The patent office will do a search. Okay, so they do their own search. They don't trust necessarily the patent attorneys. They say, we want to make sure that indeed your patent is new. And then they very rarely tell you it's all okay. They will certainly have comments on some of the parts of the patents, on the claim, etc., etc. So they will come back with a number of questions. They want you to justify why you claim certain things, etc., that you prove it, etc. And after you have answered all the questions, they will do what is called the examination of the patents. And finally, and also in this phase, there might be other loops, okay? They might come back and say, no, but you answered this. And in this process, you might still modify the text of the patent. So for example, if some of your claims are too broad, you can make them narrower. The patent office might tell you, your claim as written now is infringing other existing patents. But if you narrow it, it will be okay. And so you do it. So you work on your text. And finally, if all goes well, you have your patent granted. This is a process which costs a certain amount of money and can last pretty long period of time, like 2 or 3 years. There is an international context for all this, okay? So there is something which was done in the 1800, the Paris Convention for the Protection of Intellectual Property. And then you have a European Patent Convention and a Patent Cooperation Treaty, which is worldwide. Now, patents and publications. So I think a few concepts that you have to keep in mind is first, when can you publish without jeopardizing your patent application? The rule is very simple. You file first and then you publish after. Okay? As I say, this is not something, I will never tell anyone at CERN, don't publish your ideas. Okay, so what might happen is simply that if you really think that somebody at CERN has invented something which is really worthwhile patenting, we might tell them, look, can you wait 2 weeks? And we can be very fast. Even if people have to go to a conference in a week or 2, we can do it and say, we filed something, because the first phase of filing is not very expensive, okay? And then you can publish whatever you want. But if you publish first, you will not be able to file a patent later. Just to say that at CERN, we have a very, very developed patent policy, which covers some of the things that you mentioned. And as I mentioned, we patent only rather rarely. And then the last thing I want to stress, and this is something which I really is one of the key messages of my presentation for you. Patents are publications which can help your research work. And I tell you very briefly why. So when as you heard at the beginning introduction, I worked at CERN in the physics department as a researcher for many years. Then I worked in industry for a few years, and then I came back to CERN. While I was doing my research work at CERN, I never looked into a patent database. I had to make something new, a new amplifier for an experiment. I was exclusively looking into publication databases, okay? When I moved to industry, it was the opposite. We were only looking patent database. Why? You want to make sure you don't infringe the patent of some of your competitors. Now, that has taught me that actually patent databases are a very interesting source of information. And that's why when I came back to CERN, we have put together a course for our employees, not with the idea not to tell them you should patent more. We want them to be aware that we can help them looking in patent databases, and they can find a lot of information. They can see, because some of the things which are done by industry, which are clever, are not necessarily published, but are more patented. So that's a key message. You find a lot of interesting scientific information into patent databases. So you can see there are about 80 million patent documents. You have 2 more million patents per year. And there are a lot of new inventions published per year. And they are, as there are so many and it's difficult to search, they are classified with a very, very precise classification. I don't have time to explain all the codes, but this is something, for example, not a service that we offer inside CERN is exactly how to helping our scientists to navigate all the patent databases to find what they need. And that was my last slide. Thank you for your attention. Of course, if you want to know more, you can look at our website and you can sign up to our newsletter and you can contact me. Thank you.
Thank you very much, Giovanni. Very, very interesting. Quite out of my field, but very, very interesting and definitely useful. So let's give the floor to the students to see whether they have any question, have any curiosity.
I see that Nicola has his hand up.
Let's see if the students have questions. And first, I have 2 questions.
Nicholas, there's a question on the chat.
Okay.
I don't see. No.
Thanks, Giovanni. Is there any repository freely available to the public where they can search for inventions before even approaching patent organizations, for example, CERN?
Yes, it's called a SpaceNet. Okay, and is a tool which is made available by the European Patent Office and is really easy to use. So something that we do indeed in the course that I mentioned at CERN is to show people how to use it, but even without a course, I recommend that you go and play it. So it's called a SpaceNet. And if you go there, you will see that you can search patents for, like, for example, you want to see all things that CERN has patented, then you put as applicant, you put CERN. If you have a friend and you want to know if he has a patent, you put his name into inventor. But also you can search for keywords. So if your job is about, superconducting magnets, you can do also a search for this field. Now, there is where things become a bit more complicated. You might get a deluge of information. But I would recommend that you play a little bit with it, and then normally the technology transfer people of the organization you work for can help you with that. But yes, so the tool is called the SpaceNet, and it's something that many people don't know this exists. It's free, is relatively user-friendly, and is an interesting tool to play with.
Giovanni?
Yeah.
Can you provide the link? I think there's a request if you could just put it on chat.
Yeah,
Yeah.
sure. Let me see if I can do that. The problem, I'm not sure I have access to the chat, though. I don't see it, at least. Let me see.
You should.
Yeah, you should.
Yes, I see now. Sorry, I had to stop sharing. So let me just.
Hey, Giovanni. Thank you very much for the talk. We just want to know what would be like the first thing one should do once they have a good idea in this process, or the first thing you think we should do to kickstart the process.
Sorry, say it again. What is the question? The first thing.
Once initially, as soon as you come up with a good idea, what's the very first thing you think we should do as part of the patent process, or just to. Yeah.
So I think, the answer really depends on what your employer wants you to do, okay? Because the purpose of my presentation is not to invite you to patent more. It depends really on the organization you work for and what the objectives are. So at CERN, we don't say people you need to patent more. What we say people is that we want to make sure that your work can be used by others. A patent might be a way, but not necessarily. So in the case of CERN, we tell people, come and talk to us. I mean, if you have invented something, come and talk to us. 90% of the time, we will tell the people, look, this is very interesting, but maybe we don't want to patent it at CERN. Why don't you simply publish it, okay? If we believe that the best way to make this known to others is with a publication, that's what we will follow. So my recommendation is that you should talk to the equivalent of the KT group in your organization. That's normally what the first step is to do. And I would say do it quickly, because as I mentioned, there is something which again is not, something that doesn't fit very well with the CERN culture, is that in theory, if you want to patent something, you should not speak about it. You should keep it secret until you file the patent. That's, for me, is a bit contrary to what any researcher should do. That's why if you have invented something, you go, you talk to your KT people or technology transfer people, and then they will be able to recommend what the best thing to do. Take into consideration the strategy of your employer is, and then you will know what to do.
Okay, brilliant. Thank you very much. That's really helpful.
Nicholas, I think that can be your turn.
Thank you, Angelica. Thank you for your talk, Giovanni. This strategy of having everything published recently was challenged by a friend of mine who's in industry. He said, listen, if you are putting everything out in the open, and I'm an industry, guy or a company, and I would like to use your technology to produce a product, I'm not even sure that I want it to be so open. I'd like there to be some form of licensing. Otherwise, I could get so many competitors on the market. It just doesn't make it worth it for me to use. So this strategy of having everything open, is it still valid today, or is it starting to become outdated for certain technologies? So if you can't protect it, sometimes it loses its commercial value. How true is that?
Yeah, very good. So thank you. This is an excellent question. First of all, let me say that the beauty of our work is exactly this. Where every time we are confronted with a new technology, is understand what is the best way to make this available to others, okay? Because sometimes, as you point out, if you keep it open, you might achieve the opposite, that people say, yeah, but if everybody can have it, I don't touch it, because then my competitors will have it as well, okay? Now, first of all, this trend of being open is becoming more and more open. There are many countries which are dictating new strategies for technology transfer, like recently the French government saying we should go for software more open source, okay? So I would say the world is going more open than less open, which I think is good. And at CERN, as I said, is really, part of the most interesting part of my job is really to understand when do we need to be more closed, which is not very much in line in the spirit of the organization. And there are very few cases in which you might want to. And is primarily what I said is when you need a lot of investment to bring something to the market, that's where you probably might have to go for a patent. Otherwise, in most of the cases, open is good, in particular for software. Open source software is good. And the story of the web tells us that in some cases, being open, you actually achieve more than what you would do. I don't have a crystal ball, but I think that if CERN had done anything to try to protect the World Wide Web, it would not have become what it became. So there are a number of occasions in which being open actually helps the adoption rather than stop it. But indeed, it's a very good question. I would say it depends entirely on a case-by-case basis on the technology and the application, etc.
Thank you, Giovanni. I have another question if there isn't. There are others.
Sorry. Actually, Giovanni and Nicholas, can I just follow up from what Giovanni has just said as a comment? The French government's comment about making open access, I think there are a number of governments who are starting to do this, because what's happened is with IP and patenting, developing countries and low-income countries who don't have the same access and necessarily the same tools to be able to do that, there has been a lot of patenting of ideas, technologies, even plants and medicines and pharmaceuticals, which are being patented by high-income countries and then the countries where the stuff came from were totally left disadvantaged. So the idea of publishing and making it openly available also stops some of the countries who don't have the know how to do this being exploited. So I think there's a lot of thinking about this, that one should try to make a level playing ground.
Okay, we have then a question from a student, from Julie.
Yes, can you hear me?
Yes.
Yeah, so we have been working the last 2 years, I think, on a patent of a new radiopharmaceutical. And it has been a very long process. And my question was that we started with the process before we had a lot of in vitro data on the new compound. So my question is that we even don't know yet if the radiopharmaceutical is really working. Like, we didn't do in vivo studies yet, but still we already had this whole process of the patent, which took so much time, so many meetings with the lawyers, and maybe it will even not work. So my question is that really all worth it? Or should we really wait till we have more in vitro data, till it's, yeah, for example, shown that it's taken up by the tumor in the animal, because it has been such a long process already? Yeah.
So it's a good question. You know, the reason why you started early is because this new thing that you know, the 3 criteria to patent. Okay, so people tend to start before having all the elements clear, because you're just afraid that somebody else might do it before you. Okay, that's why. Of course, you know, is it worth it? The reason why people do this is simply because they know that not everything that they try to patent will end up being. First of all, why people patent is to make money. Okay, so that's the reality. Okay, people patent, it costs money, but they do it because they hope they will get some money back from the patent, which is, by the way, why at CERN we don't patent so much, because our strategy for KT is not to try to make money out of our technologies. Okay, but people say, okay, it's like when you buy shares in companies, you don't put all your money into one single company. Okay, you try to diversify, and when you patent, you know that when you patent many different ideas, not all will be successful, but in particular, when you talk about pharmaceutical, you know that you have a few which pay for the cost of all the rest and much, much more. So the idea is that you try to maximize your chances by taking a lot of patents, even before having all the elements to know whether they will be successful or not. And most of them will not be successful, but as a portfolio, you should end up being able to have something successful. But I'm sure that the world of patents in the next decades will have to change, also for some of the considerations that Manjit said, and also the pandemic. You know, it was something which,
yeah, but at some point it also costs a lot of money. So then you have to make the balance.
Exactly.
If you don't have enough proof, how far do you go? It's not always easy.
Exactly. Exactly.
Okay, thank you.
Welcome.
Okay, thank you. I think we have now to move to the next speaker. Thank you again, Giovanni.
Thank you. Goodbye. Thank you.